Okay, let's start by simplifying expressions. Here's an algebraic expression, 2x squared plus 3x minus 4. There are three terms in the expression, and I like to say that the sign goes with the term. Okay, the sign is part of the term. It might not say that in the books, but it's best to always, if you consider a term, to consider the sign that's with it. X is known as the variable. The two beside this x and the 3 beside that x are the coefficients of x. This is the coefficient, the 2 is the coefficient of x squared, this 3 is the coefficient, it's beside the coefficient of x. And minus 4 here is known as a constant because x is a variable. It can change from expression to expression, whereas minus 4 is minus 4. Okay, and basically, to simplify algebraic expressions, we're going to gather like terms and add them, stroke subtract them, okay, from each other. Okay, so like terms have this. So what are like terms is the question really, first of all. Well, like terms have the same letter raised to the same power. Okay, so 2x squared minus 4x squared and 7x squared are like terms because there's an x squared in each of those terms. Doesn't matter about the coefficient or the sign or any of that. Okay, x minus 4x and 2x are like terms because there's an x in each expression and they're all to the power of 1, which you don't see. Okay, and then 3, 5 and minus 6, they're like terms, they're constants or numbers. And if we just note now that x and 3x squared are not like terms because although there's x in both, it's the same letter. This is to the power of 1 and this is to the power of 2. They're not raised to the same power. They're not like terms. So let's look at question 24 from page 2 of the book. Simplify 5a squared plus 2a minus 3a squared plus 4 minus 3a plus 2. Well, the first thing is to gather the like terms from left to right. Always start with the highest power. 5a squared minus 3a squared plus 2a minus 3a plus 4 plus 2. So you can see the way you have your terms and the signs travel with the term. Okay. Then once you've gathered the terms, 5a squared minus 3a squared is 2a squared. 2a minus 3a is minus 1a, plus 4 plus 2 is plus 6. Okay. And then question 26 on page 2 of the book asks you to work out and simplify an expression for the perimeter of the triangle. It's one of the triangles from the question of the book. One side is 2a plus 2b plus c in length, the other is a plus b plus c, and the other one is a plus b plus 2c. So the perimeter is the sum of the three sides. So that would be equal to 2a plus 2b plus c, a plus b plus c plus a plus b plus 2c. Gather your like terms, gather your 2a, your a and your a. Gather your 2b, your b and your b. And gather your c and your 2c. And then 2a and a is 4a plus 4b plus 4c. So that's how to simplify algebraic expressions. It's done simply by noting what the like terms are, gathering them, and then adding and subtracting them. Okay, we're going to go on to removing brackets section of the chapter in a second. This is chapter 2 in your book, Algebra. But before we do, let's remind ourselves, if we have 3a times 3, that's the same as 3 3s are 9 and a 9a. Okay? What about 3a times a? Well, 3 times the 1 here that you don't see is 3, and a by a is a squared. Here we have 3 by 2 is 6, a by a is a squared, 3a by 2a is 6a squared. 3a times 2a squared is 3 by 2 is 6, a by a squared is a to the 3, and then 3a by b is 3 by 1 is 3, a by b is ab, and I think I have here 3a times 3b, and that's equal to 9ab. 3 3s are 9, a by b is ab. And just remember that when we multiply a by a squared, This is a to the 1, which you don't see, but it's there. And when we multiply two letters to the same letters, we simply add the bases. It becomes a cubed. Okay. And then let's look at here where we go to remove our brackets, which we did in first year. If we've a times b plus c in brackets, we multiply a by b to get ab plus sign. A by C gives us AC. And here we've minus A by plus B gives minus, minus by plus is minus, plus minus AB. And then minus by plus gives minus there. A times C is AC. So make sure you look at the first algebra primer video just to remind yourselves about multiplying anything inside brackets by a negative sign outside. So here's another example. Remove the brackets and simplify. 2x minus 4 times x squared minus 3x plus 5. Okay, so we'll just turn this over like this. Okay, and it hasn't come out too well there, but let's just remind ourselves what's written there. It's 2x. Actually, I might move this down a touch. We'll do it like this. So it's 2x minus 4 multiplied by x squared minus 3x plus 5. Okay, plus 5. Okay, so 2x by x squared is 2x cubed. Plus 2 by minus 3x is minus 6x squared. And plus 2x by plus 5 is plus 10x, and then minus 4 by x squared is minus 4x squared, plus 12x minus 20. So we look for our like terms and gather. 2x cubed, no more x cubes, let's go for our x squared, minus 6x squared minus 4x squared, and then we've plus 10x plus 12x minus 20. So that's 2x cubed minus 10x squared plus 22x minus 20. And that's the final value of that expression simplified. Now let's just, while we're facing this way, look at question 27 on page 2. Work out an expression for the question mark. Okay. So this length aside is equal to this length aside. So that must mean that 5x plus 4 plus the question mark must be equal to 10x plus 18. So the question mark is equal to all of this minus this, because we bring it over, minus 5x minus 4. So the question mark is equal to 5x plus 4. Okay, and 5x and 5x is 10x, 4 and 4 is 8, so that makes sense. Okay, let's look at question 26, page 4. Find the expression for the area of this shape and simplify with k, m, n plus k, and 2m. Okay, so the area, quick way of doing the area is this area, which is k by 2m, plus this area, which is n by m. So k times 2m is 2km, and n times n, m is nm. That's the answer. Okay. Now, let's look at examples of missing expressions from question 5, page 5, question 27 and 28. I'm just picking from different problems here. Okay. So how do we do this? Find the missing expression, which is the square box, if d times the square box equals d squared plus 5d. Best way to do this is to divide all the terms by the coefficient of the box. So there's d here, d squared divided by d, and 5 divided by d. So these will cancel, leaving this equal to, this will go into that d times, okay, because if you think about it, that's the same as d by d over d, and this one will cancel, and you're left with just d. And d will cancel here with that d and leave 5. So the missing object is equal to, missing symbol's worth d plus 5. Okay? Look at this example here. 3cd squared times our symbol is equal to 15c squared d squared. So just divide both sides by the coefficient of this. So it looks like this, and these will just cancel straight away. And then this is the same as 15 by c by c by d over 3 by c by d. So the two d's will cancel, one c will cancel, 3 goes into 15 5 times. Your answer is 5c. Let's look at evaluating expressions. So if x equals 3 and y equals minus 2, find the value of 3x squared minus 4xy minus 2y squared. And we'll use BIMDAS for this, which is in the primer video if you haven't watched that yet. Okay, so we just sub in our values. Okay, and we have 3, we work out our squared, our indices here. Okay, and then we work out our multiplications from left to right as we go along. Okay, and basically we end up with 43. That's straightforward enough, that example. Question 11 on page 6. A is equal to half a plus b all times h. Okay, if a is 9, b is 16, h is 10, find what a is. Just simply put in your values 9, 16 and 10. Work out with BIMDAS what's inside the brackets first, and then you can multiply half by 25 by 10, it's equal to 125. And you can try question 13 on page 7 for yourself. Now let's talk about solving linear equations. So if it's an equation, there's an equal sign involved, and generally if we're solving, we're looking to find a value for x, like a numerical value. So look at this problem here. Solve 3 times 2x minus 6 is equal to 2 times 2x plus 1. Okay, so 3 by 2 is 6x, 3 by minus 6 is minus 18, 4x and 2. So gather your terms, bring your 4x over, 6x minus 4x equals 2 plus 18, 2x equals 20, divide both by 2, they'll cancel, but all terms by 2, x is equal to 10. Okay. Question 32, page 8, find x. Okay, so we know these are the same length, these two sides. Okay, so you write your equation 3x plus 3 is equal to 13 minus 2x. So 3x plus 2x equals 13 minus 3, 5x equals 10. Divide both sides, all the terms basically, but divide all the terms in the equation by 5. Do one to one side, do one to the other, it remains balanced. So 5x over 5 is x, and 10 over 5 is 2, x equals 2. If you put that back in here, you'll see that it does work.